This meeting is Asian Pacific Regional Town Hall meeting for constellation of small satellite. It's organized by COSPAR, task group of this constellation of small satellite task group, organized by COSPAR. And today we have registered participant roughly 100. So at the moment we have almost 60 people online already. So at the beginning of the meeting, I would like to introduce to all the participants, the conveners and the panelists of this meeting. First, I introduce myself. My name is Ji Wu. I'm a former director of the National Space Science Center, Chinese Academy of Sciences. I will chair today's meeting. Together with me is Jean-Claude Wormer from COSPAR headquarters. He is executive director of COSPAR, sitting in Paris, in France. And we have on the convener and panelists, we have Professor Laurent Chang from National Central University from Taiwan. And we have James Park, Professor James Park from CASI, Korea Astronomy and Space Science Institute. We have, I think he was online. He's probably he will come back a little bit. You can see him from the screen. And we have another convener. He's missing now, but he will join us later. He's Professor Praveen Kumar from ISRO, India Space Research Organization. And we have also invited panelist Rudi von Steiger, Director of International Space Science Institute in Bern, Switzerland. So I welcome you all to join this meeting. And today we will have an agenda composed by 3 parts. The first part is introduction to this COSPAR activity, constellation of small satellite. And the second part is regional activities. We invited 3 talks, very short talks, concerning local, in this region, small satellite activities. And the third part is discussion. We will open to questions to all the participants. Currently, we have 67 people joining us. Welcome you all. And let's start the first part, introduction of COSPAR activity of this constellation for small satellite. And first, let's welcome Jean-Claude from the headquarters, give us an introduction. Jean-Claude.
Hello, everyone. Good day. As was said by Professor Wu Ji, my name is Jean-Claude Worms. I'm the Executive Director of the Committee on Space Research. Welcome to this webinar. This is aimed at informing the science communities in the Asia-Pacific region about one of our most recent activity in COSPAR dealing with small satellites for space science. Last year in 2019, before COVID, COSPAR has created a task group to explore the possibility of assembling an international consortium that will develop, launch, and then later acquire data from a constellation of small satellites. As background to this activity, we can refer, and Rudi von Steiger will talk at length about that in a moment, to our 2019 strategic plan, where such an activity was strongly recommended, and also to our roadmap on small spacecraft utilization, which is based on a study started in 2017 and published last year. So the co-chair, as I mentioned, of the study group, Rudi von Steiger, will later report on this activity. By undertaking this task, COSPAR aims at performing a worthwhile service to the space community and to the nations of the world, also in terms of capacity building amongst countries and institutions that presently have either little space involvement nor experience. So the COSPAR team, which is known formally as the Task Group on Establishing a Constellation of Small Satellites, or TGCSS, began its work almost immediately after the COVID-19 confinement in March, and the chairs of members of the task group will later provide briefings about this activity we've conducted so far through video messages. For your information of participants, there's an article that highlights the work done so far by the task group, published in the August issue of COSPAR's information bulletin, Space Research Today, by TGCSS Chair Dan Baker and task group members, which you might wish to refer to. In the past months, we've been polling various national bodies worldwide, and we've started to gather a significant number of expressions of interest for our initiative, with a very large response rate, particularly in the Asia-Pacific region, and I'm very happy about that. The ensuing discussion will address what elements these bodies and nations might wish to offer as support, and ideas on what various parties can do to help support the proposed small satellite infrastructure. COSPAR, for its part, will play the role of a honest broker, facilitating the process, establishing scientific priorities for the first constellation or constellations of satellite, and generally acting as an independent interface between the various stakeholders. Naturally, further funding for this activity should come from these national bodies and entities that have expressed interest in the activity. Following this second webinar today, we had a first event for the American region on 2nd September. We will have a third event for the European, African, and Middle East regions at a date that is yet to be determined in October. Professor Wuji talked about it already somehow, but the format for this webinar, we will have a video introduction by the COSPAR President Len Fisk, recalling the rationale for COSPAR to engage in that domain. Another video by the chair of the task group, Professor Daniel Baker, who will brief us on the work done so far by the task group. They apologize for not being present in person. This is due, of course, to very different time zones. The number of speakers will be introduced by Professor Wuji, and they will explain the state of small satellites-related projects in their countries and institutions. And they will intervene panelists and task group members during the ensuing discussion. I see we have the pleasure of hosting today almost 70 view-only attendees. They will have the possibility, of course, to ask questions, offer comments and suggestions at all times during the presentation. And please do avail of this opportunity. The chair is Professor Wuji. Ms. Laura Valdis will attempt to group and channel your questions. She's from EC Beijing. I take this opportunity to thank her warmly for excellent organization of the webinar. It should last 1.5 hours, so ending around 11 a.m. CEST, 5 p.m. Beijing time. So I'm done. I guess then the next item on the agenda is Professor Len Fisk by video. Thanks again for your contribution.
Thank you, Jean-Claude. When I have the introduction, I forgot to introduce our controller. This webinar controller. Laura Badis. So she's helping us very much to organize these activities. Now let's go ahead with Len Fisk's video introduction.
I would like to welcome you from the safety of my home to this town hall meeting on science questions that can be addressed by constellations of small satellites, and to express my gratitude on behalf of COSPAR for your participation, and for the guidance you will provide on how to implement concretely the objectives of the COSPAR task group on establishing a constellation of small satellites, or as we like to call it, TGCSS. Several events led to the establishment of the task group. During the roundtable discussion at the COSPAR Symposium on Jeju Island in 2017, NASA Associate Administrator Thomas Zurbuchen introduced the concept that COSPAR could help coordinate a constellation of small satellites provided by many nations, and by doing so would promote international cooperation and help spread space technology to many nations. The COSPAR Roadmap on Small Satellites for Space Science, published in 2019, explicitly called for COSPAR to help coordinate a constellation of small satellites. The strategic seminar, held in December of 2018, to chart COSPAR's future, recommended the establishment of the task group, and the TGCSS was highlighted in the Strategic Action Plan that COSPAR adopted in March of 2019. The task group and your participation in its activities is thus of considerable importance to COSPAR. Moreover, it is my belief that the importance of a constellation of small satellites, with satellites contributed by many nations, transcends the usual COSPAR mission of promoting international cooperation and spreading space technology to many nations. It is, in fact, an effort that can contribute to world peace. Indeed, we live in a time of increased militarization of space. It's the dark side of our growing dependence on satellites. If there was ever a major conflict, or even a threat of a conflict, between nations that depend for their survival or their capability to wage war on their satellites in orbit, then these satellites would be the first to be attacked. Thus, as more nations have access to and capabilities in space, militarization of space is underway. It is reasonable to assume that these same nations are developing the capability to defend their space assets or, if need be, to retaliate. And there's no treaty to prevent this. The United Nations Outer Space Treaty of 1967 prohibits the placement of nuclear weapons or other weapons of mass destruction in space. However, it does not prohibit conventional weapons, such as kinetic weapons or lasers that can destroy satellites. One way to help avoid conflict and confrontation in space is to have programs such as the constellation of small satellites, in which all spacefaring nations, big and small, contribute, thereby collectively claiming space as a global commons, a resource not owned by one nation but crucial to the future of all humankind, a global commons in which every nation with relevant capabilities can conduct space research, all for peaceful purposes, a global commons where cooperation is encouraged, competition is discouraged, and conflicts are forbidden. What you do here today, therefore, is important. The constellations of small satellites that you're helping to develop will promote the concept that all spacefaring nations have a vested interest in maintaining space as a peaceful domain. I wish you success in this important work.
Okay, thank you, Laura, to play the video. And next, we will have the chair of this task group, Professor Daniel Baker from University of Colorado. Due to the time zone, he cannot attend our meeting face-to-face. So he has already also recorded a video for us. So Laura, please play the video from Dan Baker.
One second. Okay.
Hello, and welcome to all of you to a COSPAR Town Hall webinar. My name is Dan Baker. I'm the chair of the task group for employing constellations of small satellites for space science applications. I want to welcome all of you to the Asia Pacific sector this morning, this evening, this afternoon, whatever time it may be for you. We're delighted that you can be here, and I want to share with you a little bit about what the task group is, how it came about, and what our objectives are. Let me begin by just saying that there has been a worldwide revolution in the use of small spacecraft for space applications and scientific purposes. This is an image that dates now back over a dozen years, but it was put together by myself and General Pete Worden to talk about the NASA small spacecraft missions that had been carried out up to that point, and many of which have continued at the present time. These small spacecraft were initiated by NASA. I was privileged to be the first project scientist for this mission when I was at NASA. And many of these spacecraft have revolutionized our understanding of the sun, the Earth's magnetosphere, and astrophysical bodies through the galaxy. The fact of the matter is that in this article, Worden and I talked about how small spacecraft could be amazingly beneficial going to the future, but few of us could have envisioned what a revolution there really would have been in small spacecraft. So, as has been alluded to by Dr. Fisk, the task group was put together in late 2019. The origins of this were based in the COSPAR strategic plan. And these words from that strategic plan highlight what some of the vision really was for this program. And as it says, there was a goal to have a demonstration of COSPAR's value to the members around the world. That's important in space research. COSPAR was expected to explore the possibility of putting together an international consortium that would develop, launch, and acquire data from constellation of small spacecraft, as it says here. It will also be important, as they noted in this plan, that the constellation really provide useful scientific data, important scientific data, and contribute to the understanding of our universe. And it was noted that a particularly useful constellation could be one that was focused initially on space weather forecasts, focusing on the Earth's ionosphere. The task group was assembled in late 2019 and early 2020. This shows the membership. I'm privileged to be the chair of this task group. And many of the individuals here from the Asian sector will be running the webinar for you today. And we're delighted to have such broad representation from around the world. My colleague Amal Chandran represents Singapore, Lauren Chang from Taiwan, James Park from South Korea, Praveen Kumar from India, and Ji Wu from China. I'm sure they'll all be with you today. But we have tried to have representation from around the world and those with particular passion and involvement in small spacecraft. We really got our task group together and began deliberation just about the time that the world was shut down by the COVID-19 virus, unfortunately. But we've carried out our business via Zoom meetings, and we are delighted that we've had the chance to consider many key issues concerning the task group charge. This includes looking at issues of small sat design, system engineering, spacecraft bus characteristics, issues of access to space, ground system and communication issues, and of course data archiving, sharing, and standards are also an important component of this. There are many points of consensus that were quickly arrived at by the task group. This included that COSPAR should be truly an honest broker. It should take a grassroots approach. COSPAR will not and does not have the resources to fund all of this, but it can help to make things happen. It should be a bottom-up, not top-down kind of approach. And there are many structure and framework issues that COSPAR can play a crucial role in, soliciting contributions, helping to enforce and reinforce the activities around the world, and supporting launch and data efforts in particular are things that COSPAR is very experienced with. and it's expected to play a large role. There are two distinct aspects of the action plan that our task group has focused on to this point. One branch was expected to be geared toward harnessing the power of the current worldwide revolution in small sats that I talked about. And we believe that the nations and the institutions that are so involved in small satellite work can band together and can accomplish tremendous things by working cooperatively around the world and over time. But a very crucial second branch of the committee's work, of the task group's work, would be to build capacity among nations and institutions that at present have little or no space involvement. And this is perhaps as important as anything, is to allow more organizations and nations around the world that want to be involved in space to demonstrate their capabilities and to earn a seat at the international table. So the goals of this webinar are to share more of the present task group thinking about the constellation of small spacecraft, to build more grassroots interest in this COSPAR program, to really solicit ideas from all of you, from the small sat community and those who want to be part of the small sat community. And as I noted, to engage new institutions and researchers. We hope that there are many of you on who are just learning about this and who want to bring your institution and your individual researchers to bear on these important science problems. And we really want to answer your questions. So I'm sorry I couldn't be there with you in person today, but I want to thank you for joining this webinar, and I wish all of the participants the very best. Thank you very much.
Okay, thanks, Laura, to play the video. And here you can see the goals and what we are doing at the task group. And we are waiting for your questions at the end of this meeting. And next, we would like to invite director from EC, Switzerland. He, Professor Steiger. He is chair of this COSPAR roadmap on small satellite for space science. This is also another very important background of this task group. So next, please, Professor Rudi von Steiger. We cannot hear you. Can you switch on your microphone? Okay.
Can you hear me now? Okay.
No,
I'm
yes,
going
yes.
to share my screen. Thank you, Professor Wuji, for giving me the chance to introduce you to the task which preceded this task group, namely the putting together of a COSPAR roadmap for small satellites for space science. I'm going to share my screen. Laura, can you please tell me if it's visible?
Works properly.
Okay, good. So this group, which put together a COSPAR roadmap on the use of small satellites for space science, or 4S, was put together by a group of 20, something like 20 people, including some of those which are on the panel today. And it was co-chaired together by myself, together with Robin Milan, who obviously cannot be here due to time zone considerations. The title here is on is 3 satellites from the QB50 constellation, which I will come back to in just a few minutes. This COSPAR roadmap on the use of small satellites for space science has in the meantime been published in Advances in Space Research. Up here you find the link to the DOI of this paper, and it is freely available under open access in Advances in Space Research. So please help yourself to a copy of that paper. This international study team was installed under the auspices of COSPAR. It was focusing on small satellites, not just CubeSats or CubeSat-enabled technology-enabled small satellites, but anything smaller than a loosely defined limit of 250 or 300 kilogram. That's what we considered small satellites. And also the meaning of space science was meant to include all scientific disciplines covered by COSPAR, and that explicitly includes earth sciences. The charter of this committee putting together the roadmap was to evaluate and picture the status and scientific potential of small satellites, investigate the roles of agencies on the one hand, industry on the other, dive into policy considerations that could support or otherwise hinder the development of small satellites, and investigate models for international cooperation and partnerships. Previous work, previous to this roadmap, was put together in an NRC report in 3 publications, one of which being an NRC report 2016 with Thomas Zurbuchen, one of the editors. Thomas actually was also to co-chair together with me this roadmap, but his employment at NASA came, and of course he then would have needed to drop that engagement. Number 2, there was an ISSI forum on performing high-quality science on CubeSats in 2016, and in 2017, the Palia Lal edited an IDA report on global trends in small satellites, all 3 of which are referenced in the COSPAR roadmap. The roadmap document, sorry about my phone, I'm just going to ignore it, so please ignore it too. The roadmap document has 3 parts. The first, as by the charter, was reviewing the history and tradition of traditional small scientific satellites. And here you see a graphic figure illustrating how that importance has increased in recent years, but just illustrated by the number of small satellites launched, and for many of which, but the majority still not for space science. The second part of the roadmap document delved into a few visions for the future. These were not meant to be proposals for missions, but meant to be visions for the more distant future in order to sharpen our appetite, whet our appetite, and illustrate what could be done by small satellites. 4 such visions were illustrated in the roadmap. The first one, a large constellation for Earth observation. Now you will say that's already being put into orbit by commercial companies such as Image or others. But of course, this roadmap was to be about the scientific use of small satellites and a large constellation for Earth observation. There is still much to be done to make it useful for space science. Number 2, we investigated a swarm exploration of a solar system body, such as, for example, the comet Halley, when it will return the next time in 2061. Number 3, a small satellite synthetic aperture telescope was one of these visions, under the impression that James Webb, which is hopefully going to be launched successfully next year, is just about the biggest thing you can, if you carefully origami fold it into the fairing of a large rocket. There can't be any larger telescope launched in one piece, so the obvious thing what to do is to have a synthetic aperture telescope made from small satellites and put together with formation flying, highly accurate formation flying, of course, to optical wavelengths, in order to give us a large telescope. And finally, we were delving into an interstellar mission, such as the one propagated under the label of Starshot. Number 3, I'm sorry, I just skipped. Yes, number 3 was investigation of the obstacles and the means to overcome them in order to bring scientific use to small satellites in space. Funding and policies were investigated. ITAR, for example, is always an issue. The critical role of the government and agencies and government agencies and industry was highlighted, and several models for partnerships were investigated and presented, including one involving secondary education and workforce development. The roadmap document concluded with 5 recommendations, each addressed to a different segment of society: the scientific community, space industries, the agencies, the policymakers, and finally, COSPAR. I'm only going to highlight the 5th recommendation to COSPAR, that COSPAR should facilitate the process whereby international teams can come together and define the science goals for a QB50. QB50 was a European Union program initiated by the Belgians of 50 CubeSats launched with a small number of standard instruments, but to enlarge that into a modular international small satellite constellation. I'm not going to repeat, you can read that for yourself. I'm only giving you the 2 main ingredients. Number 1, COSPAR, of course, cannot fund anything like that. That's where its role as the honest broker came about. That goes back to this roadmap document. And number 2, so yes, number 1, honest broker role of COSPAR. Number 2, the fact which already Dan Baker highlighted, it is to be a bottom-up activity, a grassroots initiated activity, not a top-down activity, for reasons that are amplified in the roadmap. So that's where we are. COSPAR introduced this task force, which Dan Baker already highlighted for you. This is the beginning, and we are about to leverage the existing international efforts. And this is now where we need you for coming together at future events at COSPAR, brainstorming on constellation missions for the future, space weather being only one or the first of these, but then it could go much broader than that. And for that, we rely on the great ideas which will come from the community, and that is you. With this, thank you very much. I will give back to Professor Wuji.
Thank you, Rudy. Thank you very much. It's very clear that we have the current activity of the task group is just following the recommendations, and the COSPAR leadership, we are organizing this meeting to call your attention and to have your support from all the nations and institutes to contribute. We hope we can form up a constellation later on. Thank you, Rudy. If you have any questions, since Rudy is here, and we have also our headquarter executive director Jean-Claude is here, so we can ask questions about those general questions later on. So in the next session of this meeting, we invited 3 short talks from regional activities. It's not all covering all the activities, but has some as an example to tell you what is going on already, but it's limited in dedicated countries or regions or institutions, agencies. But it may help for you to think about how to constellate small satellites together and to perform some activities. So the first presentation is given by Professor Wang from National Space Science Center, Chinese Academy of Sciences, and his talk is on a mission called MUSE. Professor Wang, could you go ahead?
Yeah, hello.
Okay.
And could you see my screen? Or just could you see my presentation here?
Full screen.
Yeah.
Now it's editing mode. Yes, now it's okay.
Okay. Thank you, Professor Wu, and thank you for the invitation. And today I will present the MUSE mission, a multi-scale current density and magnetic field structure explorer. It is a CubeSat mission for the space science. Okay, let's start with a scientific background. We all know that substorm has a great influence on human activities in communication, power grid, spacecraft, and astronaut safety. Substorm is a brief disturbance in Earth's magnetosphere that causes energy to be released from the tail to the magnetosphere and inject into the high latitude ionosphere. Okay, the left figure shows that during a substorm, the magnetotail plasma moves towards the Earth and injects into the polar region. That is the most intense region of energy coupling. So here we can see the structure of a substorm. The energy transfers from the tail to the region, to the polar region. And then we got scientific objectives. That's in situ current density measurement of polar region and ionosphere. Though we want to measure the distribution and exchange of the current density of polar region during substorm. The left figure shows the current system in near-Earth space, and then the right one shows a current system in the polar region. Here, to measure the distribution of current density in the upper ionosphere, it is quite challenging for a single spacecraft mission because we want to also measure a multi-scale magnetic field structure explorer. From the left picture, you can see with only one orbit measurement, we cannot know a fine structure of magnetic structure of flux rope in a current sheet. And the right one picture here shows a multi-scale plasma and magnetic field simulation result. We can see there's a lot of fine structure in the polar region here. And currently, we do not have any method to measure this fine structure. So we want to use a small satellite constellation to solve these problems. First of all, how could we measure the current? Here, if we build a 3-satellite constellation, we can know that a current density could be derived from magnetic field measurement. So with 3 satellites, we could find that the current density perpendicular to the in situ plane. And if we add another one, we got 4 satellites, we can derive the current vector in a 3-dimensional. So this is a principle of the current system measurement. Here is our preliminary design and simulation of orbit and the spacecraft formations. Here we suppose that the spacecraft will separate from the launcher, and then we build a 5 CubeSat formation. And the 4 sub-satellite will have active orbit control during this separation. So here we can see the green part is the orbit control part. Then we got a constellation of the small spacecraft here. And from the right video, you can see how the 5 spacecraft formation was built. And at any time, it's built a measurement matrix in 3-dimensional. Then we can measure different directions of the current density. That is orbit and formation design for our mission. And then we also did some analysis on the CubeSat number. What if we have 3, 4, 5? What will be changed? So after a dedicated analysis, we found that with a 5 CubeSat formation, the measurement error will be much lower than 4 satellites. And it can cover all the orbit area. That's why we need 5 small satellites. Okay, then I will introduce about the payload. The magnetic field is only measurement only when we should measurement. So the only one payload is magnetometers. For small satellites, we need a very light and very small sensor head. So we developed a AMR magnetometer with 2 3D vector sensors here and a deployable boom, the blue one. It's built a gravitational measurement to cancel the magnetic field caused by the spacecraft itself. And the mass of the sensor head is only 20 grams. It's very light. And measurement range fulfills the Earth's magnetic field. And we got a lower than 0.1 nanotesla's noise level. And here's a block diagram of this magnetometer. The upper shows a traditional flux gate magnetometer. It's much bigger and heavier. And the lower one is AMR magnetometers. The electronics part are similar, but a little bit simpler than that. So we can decrease the power consumption and the mass to fit a small spacecraft platform. We also did an engineer model for these AMR magnetometers. We have a lot of tests on it. We have tested the linearity here and the measurement range and the noise level. And also we built a long-term test to verify its stability. So after this test, we can know that currently the AMR sensors could fulfill our scientific objectives. Here I will introduce about the spacecraft conception. The left figure shows the combination of 5 spacecraft. It will be launched together, and in the middle sits the main satellite and the 4 sub-satellites around it. And the right one shows the sub-satellite and the main satellite after separation. The boom will be deployed soon after the separation, and for the small one, the boom will be 1 meter long, and for a big one, the boom will be 1.6 meters long. And for the main satellite, the weight will be around 50 kilo, and the sub one is around 10 kilo. Beyond that, we also have built some engineer model for the MUSE mission. For example, the main satellite and 1 sub-CubeSat, we built it with the 3D print process, and also we have tested the boom. We also did some deployment test on ground to verify the functional of the boom, and also we have calibrated it to verify the characteristics of this engineer model. Okay, we got let's come to a short conclusion. The MUSE mission is a CubeSat space science mission focused on the substorm research, especially on the polar region. And it will help us to understand the magnetosphere, ionosphere, and thermosphere coupling process. In order to fulfill our science objectives, we have built a 5 CubeSat constellation conception, and we have designed the orbit and formation. We also verified the engineer model and also tested the payload. That's the current status of this mission, and that's my last slide. Thank you very much, and wish everybody safe and healthy, especially in this special situation. Thank you for listening.
Thank you, Professor Wang. It's very interesting, but there are only 5 satellites. We need much more. So this is only introduction to our future activities. Next, let's have Professor James Park. He will present the activities in CASI. It's a constellation of small satellite. Professor James Park. Okay.
Thank you, Ji. Can you see my screen?
Yes, we can.
See it. You can play it, yes. Okay, very good.
Thank you. Good morning, good afternoon, depending on your time zone. I'm glad to give the brief information of small set program in Korea. The history of space program in Korea was started from late 80s, and the first satellite manufactured by Korean colleagues was successfully launched in 1992. The name of the first satellite is KISAT-1, as known as River 1, was just small set, weighted around 49 kilograms. In the last 3 decades after KISAT-1, Korea launched more than 30 small satellites into the space, as shown in this table. And the first CubeSat in Korea was HOSAT-1, which was launched in 2006. After that, so almost more than 20, a few dozen of the CubeSat had been developed by the university, research institute, and private companies. The purpose of the CubeSat are also observation, science, technology validation, and education. So currently, almost the same number of CubeSat, which were manufactured in the last 15 years, so have been developing for forthcoming missions. Today, I'll talk about 2 CubeSat constellation programs for space weather. First one is a SNIPE, which stands for Small Scale Magnetospheric and Ionospheric Plasma Experiment. The scientific goal of the SNIPE program is to identify temporal and spatial variation of a small scale space plasma structure. So SNIPE program consists of 4 6U CubeSat equipped with a Raman-Fock solid-state particle detector and magnetometer. The SNIPE satellite will also carry the iridium communication payload and gamma-ray burst monitor for technology demonstration. The design life of the SNIPE satellite is 1 year, including the 6 months science operation time. So CASI has been performing the SNIPE project from 2017 and finished CDR in November 2019. The SNIPE satellite are scheduled to launch in next year by 3 launches. SNIPE program satellite will be deployed at about 500 kilometer altitude in sun-synchronous orbit, and will be slowly separated from 10 to the more than 100 kilometers in cross-track formation after the 2 or 3 months long-term formation following to the formation planning concept of SNIPE program. Second program is CASTNet, created by the Korea Space Weather Center. The mission of the CASTNet is to acquire the in situ observation data of ionosphere and magnetosphere by CubeSat constellation to increase the capability of space weather forecasting. CASTNet program consists of 2 phases, totally 6 years, and will consist of 40 3U CubeSat as a baseline. The number and the size of the program satellite are not fixed yet. So candidate payload of CASTNet are plasma detectors, a particle detector, and a magnetometer. And also the GNS radio occultation payload was also considered as a candidate. This program will also include the development of data simulation model for space weather forecasting. Korea Space Weather Centers have performed several studies on space weather forecasting and planning this program in last year. This program was introduced at the COSPAR TGCSS meeting as one of the potential candidates to make the COSPAR constellation for space weather. This is concept of the CASTNet. That's all. Thank you for your listening.
Very good. Thank you, Professor Park. It's good to focus on space weather because this is the first stage for our task group. We will look at space weather first. So those are very interesting questions to address. Next, let's have Professor Kumar to present small satellite activities in India. Good, we can see it. Please go ahead.
Yeah, is it visible?
Yes.
Yeah. Okay, so this today's presentation, my colleague is also here. It's the Rajiv Senan. He will be presenting on small satellites, and the remaining portions I will be presenting. So I welcome Rajiv Senan to present the small satellite part.
So good day to all. Am I audible?
Yes, please go ahead.
Yeah. So I'll be presenting the small satellite capability within India. So actually we have the small satellite buses for the nano satellite as well as the micro satellite. So this gives the figure of the INS-1C nano satellite. We have already launched 3 nano satellites. So 1C is the last of that, and this gives the payload mass as well as the total mass of the satellite. It's around 12 kg, where the payload share is around 5 kg. So it's around 40% of the satellite mass comes for the payload. And the volume details are given. This satellite is capable of generating around 10 watts of power. The data storage is around 8 gigabyte bits, and the download rate of 1 megabits per second. Being a nano satellite, the design life is around 6 months, which is ample time for doing this type of experiments. And our previous satellite also was an Earth observation satellite, and is given good images of the cloud as well as reasonable comparable with the conventional satellites or INSAT class. And we have the next micro satellite bus. We have 2 buses. One is that Indian microsatellite bus 1 and 2, which is capable of having around 100 kg and 450 kg with a payload mass of 30 kg and 200 kg respectively. And this also is a much higher capability with the power generation of 230 watts and 675 watts respectively. These are for the end of life, and it has more generation possible at the beginning. And data storage of 16 gigabits and 32 gigabits with a download rate of 8 megabits per second and 100 megabits per second. And these satellites have a mission life of 2 years to 5 years. The IMS-2 have around 5 years of satellite. And these also we have already flown more than 6 satellites in both 2 satellites in IMS-1 and more than 4 satellites in the IMS-2 bus. So these are the capability with respect to small satellite. And the launch, if you know, we have the PSLV vehicle, which is the workhorse vehicle of ISRO, with already 50 launches done from 1993 onwards, and almost 47 with a 94% reliability. It was a vehicle capable of doing multiple launches in different orbits. The capability of around 3.8 tons in low Earth orbit and around 1.75 tons in the SSP, or what is called as the sun-synchronous orbit, and around 1.4 tons in the sub-GTO. So normally our missions are sun-synchronous orbit. Altitude is around 500 kilometers with the inclination near polar of around 97.4 degrees. So if you have the PSLV C-37 mission, which is the record mission of ISRO, where in the single launch we have flown around 104 satellites. That is out of which the 3 main satellites, the main payload was the CATO payload, and the 2 nano satellites, INS-1A and 1B, and the remaining 101 satellites were the passenger payloads from USA, Netherlands, UAE, and Israel. So totally of around 101 CubeSats, each weighing around 4.6 kg, was deployed during this single mission of PSLV C-37, which was in February 2017. And next, I'll hand over to Dr. Praveen to the space for the.
So good day to all of you, and I will be covering this science part and training part of this small satellite programs. So in order to have an effectively addressing this science of space weather, which require some multi-pronged approach with theory, experiments, observations, and modeling. So we have the capabilities in all these areas, and also our institutions and institutes, they have shown keen interest in all these above areas. The experimental systems include space-based measurements, which includes the radio beacon experiments, experiments on board orbiting platform PS4. PS4 is the PSLV, that is Polar Satellite Launch Vehicle's fourth stage. After inserting our main satellite in its orbit, that platform have been utilized for conducting experiments by using small satellites. And the upcoming Aditya L1, that is India's first mission to study sun. That is also specifically, very important mission for space monitoring, space weather monitoring. Then we have also these rocket-based experiments and innovative instruments for ionospheric observations, mainly from Tumba Equatorial Rocket Launching Station, as well as from SHAR. And in addition to that, we have a well-equipped ground-based measurement network stations, which includes radars for probing the atmosphere and ionosphere, and also a wide network of GPS and IRNSS receivers, magnetometers, and optical experiments, in addition to ionosondes at identified locations. And another important one facility what we have is the multi-application solar telescope, which is situated in Udaipur Solar Observatory in Rajasthan, which can also supplement a ground support to the space weather studies. And in addition to that, a high altitude balloon facility for experimental studies for calibration of the instruments and other things, we could utilize this facility. Of course, then we need to have theoretical studies and state-of-the-art numerical simulation models, which are also very important for the space weather studies, which can also be carried out in India. Now, as we all know that even training is also equally important in this area. So at the 50th anniversary of Unispace in July 2018 at Vienna, India announced a capacity building training program. In short, it is UNNATI, that is Unispace Nano Satellite Assembly and Training by ISRO. Actually, this training program consists of mainly two modules. One is a theoretical module and the other one is a hands-on training. And we have already conducted 2 batches of this training program. And one more batch is there because of this present pandemic situation. We could not conduct it. And with this, I am concluding my talk here. Thank you.
Okay, thank you very much. It's all this information are building blocks for the future constellations. I think it's very encouraging, reflecting our activities in the region. Now we can open to the questions to the audience. I prefer the questions are aiming at the general tasks of this task group, and how to form this constellation and how to organize particular technical questions to the 3 presentations. We can hold it a little bit because it's not a technical meeting. It's not a technical symposium. So let's concentrate on the organization and about this constellation and how to contribute from each institute to this. Or you have questions asking for the COSPAR task group. Yeah. Please go ahead, the participants. I can see we have still 70 participants in the meeting room, and at the maximum is almost 80. Yeah. You can type in your questions into the chat box. Currently, we have a few already. Maybe let me see. In order to let people think about to submit questions, we can have Professor Wang to answer. There's question towards you on how the mission is deployed. Are those 5 satellites deployed in one launcher or not?
Yeah, hello. It's a quite good question for the Muse mission. And the first one is a question about the boom. The boom itself was quite simple. I think it's much simpler than a traditional segment boom. You can see here, there's no hinge, no springs on it, and it's only made by carbon fiber. It's designed with carbon fiber tube, and with dedicated design, the boom will deploy with its own elasticity. So this part is quite simple, much simpler than traditional boom, and it has been tested on ground. We have tested for the accuracy after several times deployment to see if it will be deployed properly and the angles will be proper to the original position. That's the question about the boom. And the second one is about the launcher. Yes, this from my presentation, you can see the main satellite and the 4 sub-satellites was combined together and will be launched together. After the launcher separation, then the main satellite and sub-satellite will be deployed, will separate again to build the.
Okay, we don't have to go to that details. So it was launched in one go, in one launcher. Yeah, yeah, it will be launched in one go. Yeah. So there's a question about the COSPAR mission, whether it can does it contribute to the space debris? Maybe Jean-Claude, you can give the answer. Yeah.
Yes, thank you. Indeed, that's an issue that will need to be followed cautiously because, as we know, we are in the midst of a revolution in launching constellations of small satellites. And when you look at the plans, for instance, from the private sector, whether we're talking about SpaceX or Amazon or OneWeb, and here the magnitude of these constellations is in the tens of thousands of satellites in the years to come. And this is an issue that is already addressed by a number of scientific learned societies. For instance, the International Astronomical Union has set up working groups together with a number of private sector representatives, including SpaceX, to try and address this problem. Because on the one hand, there is the debris issue that you mentioned, which is real, that will need to be assessed, monitored, and followed using international good practices here. But there's another aspect, for instance, which is linked to the light pollution, which will be detrimental to astronomers. There's also radio astronomers, etc., etc. So these are being addressed by these, for instance, the IAU. But COSPAR has been discussing with IAU to try to support them in their efforts to try to find ways to mitigate the problem and certainly address it. So, but I just want to point to one element again, referring to what I said 30 seconds ago, which is that the magnitude here is considerably different. These problems that will be that astronomers will face, that other satellite operators will face because of debris, will result from a huge number of satellites, so tens of thousands of satellites. What we're talking here concerns a very, very small initiative by comparison, a few dozen satellites. And so the order of magnitude is simply not the same. It doesn't mean that we should ignore the problem. It should be part of the same set of guidelines that we need to follow. but still the magnitude is very different.
Thanks, Jean-Claude. I think in the task group, we will discuss this issue also, and we are not trying to generate more debris in the space, but for example, I can take the example of CubeSat 50. CubeSat 50 is, there are 50 satellites, but they are running in a very low Earth orbit. So it will be descending very quickly. So there's a lifetime for them. So once you design our mission, we could design the lifetime and design a correct orbit, high altitude, then it will disappear in a few years, in a limited time. So maybe I could briefly answer a few questions, like number 6 is asking how a private organization can participate. We are collecting a list of interested unit, like private companies and institutions can also, private company can also show your intention to participate. But once the constellation is defined, you will have to pay it yourself. So COSPAR does not have a funding, so you will have to look for fundings locally from your agency, from your government, or from your foundations, and to participate. COSPAR will only organize this constellation and trying to coordinate which spacefaring countries to launch it and to acquire the data. So COSPAR will not pay for the mission. So that will probably answer your question. And there's also a question asking, is there a forum to discuss, to design the mission? And at the moment, our task group is only at the beginning. So next step is probably we will organize a definition team and to define the scientific objectives of this mission. And then there will come a requirements for how many satellites and how to perform this constellation. So that will come later, and when we have that, we will announce it. And next is whether it will go deep space. So we will not go to deep space at this stage. The first phase of this constellation is only looking for space weather issues dedicated for space weather research. So that is question number 9 is also industry participation and funding. I have already answered that question. And question number 10 is small satellite definition is too large. Okay, so that is that is a definition issue. We could when we come to the definition phase, we will limit how big the satellite is, because we will have to say how much, what is the weight, how many satellites we will have, and we have to coordinate a launcher. So the individual spacecraft will be defined at that time, not now.
T, can I complement some of your answers?
Yes, please go ahead. Yes, maybe I was wrong. Yeah.
No, not at all. No, I just want to complement that. Okay. I think what you said regarding funding and contribution is perfectly correct. I just want to say that on these matters, clearly there are a number of issues that are not yet solved. As you said, the task group is at the beginning of its life, and it's in the process of setting up Tiger teams in order to address some of the pending questions, and there are many. As you addressed a few, financial issues are one, in-kind contributions are another. How can the private sector contribute? What would be, for instance, would there be some kind of legally binding mechanism for these entities to contribute to the constellation? All these issues will be addressed by these Tiger teams, this subgroup, if you wish, of the task group. And this is something that we'll be able to provide answers to in the next few weeks and next few months as they are being developed. COSPAR can certainly act also as an interface with the space agencies in order to establish whatever mechanisms are necessary to enable the development and launch of these constellations. So this is also something that we can do in our next events. For instance, the next assembly that will be held in a hybrid format at the end of the month of January. There will be a roundtable of space agency leaders. This can become part of the discussion there on how to ensure that the space agencies worldwide can support this initiative from COSPAR and what the coordinating role COSPAR can play there. So yes. This means that basically in the end we might have to, for instance, set up memoranda of understanding with some of you to be discussed and agreed upon at the second stage. So this is something that we'll be glad to further discuss with you. If you have interest, as we have already started to gather this interest, as G was saying, in America and other regions. If you have interest in participating, please contact us, the task group, the COSPAR Secretariat, and we'll continue the discussion in order to make these collaboration concrete. Excuse me.
Thank you, Jean-Claude. It's very good information we provided. And on the question number 11, I like it very much. It's concerning whether the constellation can cover ionosphere and magnetosphere altogether simultaneously. This is a very scientific input. We will discuss it on the definition team. We don't know how many contributions, how many satellite, CubeSat or SmallSat we will have on this constellation. Maybe 50, maybe 100, we don't know. So once we have that at the definition team, we will see whether it can be possibly covering quite a lot of geospace. It may be also depends on the launchers provided. If there are more launchers provided, we could launch in two goes, not in one go, and then we could cover two regions and measure them simultaneously. So this is a good question, but we will address that later at the definition team. And question number 12 is also very good. Is asking whether the constellation can combine satellites from different countries. Yes, of course. This is what we are doing. COSPAR is organizing contributions from different regions and countries, and definitely not one country, not even two countries, three countries. We should have more countries to contribute. So as many as possible, as long as it's within this definition for the address of the same scientific questions. So that is quite obviously we will organize as many countries as possible. And question number 13 is there any how many agencies has already showed their interest to contribute? And this is the next step. So COSPAR will acting as an honest broker to talk with the different government agencies and to see whether the only thing I know is from China we can provide data or operational centers. This has been shown already. So if there are any other agency would like to show their interest, they can just go to any member of our task group or go to the secretary of COSPAR. Jean-Claude, please.
Yes, to complement that, we've already started to receive a number of expressions of interest, because one of the first things that we did when establishing the task group is to send letters to our national committees and national representatives. And as a result, we collected some marks of interest. No commitment to fund the issue or no commitments to provide in-kind support yet, but there was a large interest from a number of countries and entities. Some are listed because they were, they wrote to us and said, we're interested, so we listed them on our website. If you go to the COSPAR website, cosparhq.cnes.fr, there's a special page there dedicated to the task group, which you will find under structure. And there at the end of the page, you will find the list of the organizations that have currently expressed interest. For instance, you mentioned agencies, so there's a UK space agencies, there is support from potential support from Russia, from Korea, from Spain, from Taiwan, from Israel, from China, as was just mentioned. I know that unofficially there's also a large interest in NASA and ESA for these activities as well. It needs to be made more concrete, but it does exist, and we'll update that list as it grows.
Yes, very good. When I look at the following questions, many of them are concerning technical issues. For example, how many satellites, how do we organize them? And this is definitely what we are going to discuss later on by this task group. Currently, we are just collecting information and interested institute. We have a list of roughly more than nearly 100 institutes are interested, or private companies even interested. So if you are interested, you just provide your information to the task group members or to COSPAR headquarters. And so we are estimating more than dozens of contributions already. So the number of this constellation is not small. It will be large. So during the next step, we will discuss how to organize such a great number, and I believe it will contribute for very good for science understanding of space weather. So that will be a very general answers to you. Other panelists, do you have any comments? And when you look at the questions, and you can add on. Yes, there's a question concerning ground networks. This is a very good, because space weather can be measured both in space and on the ground, and the ground contribution is also welcome, because we are addressing science. We are not addressing an engineering issue, and not to launch a satellite, just launch a constellation of satellite. We're addressing science issue. This is a COSPAR's duty. So when we define science objectives, if there's contribution from ground measurement, it will be very good to add on this data. So the future data center will combine those data together and to provide those data altogether to the scientific community. So we are welcome any contribution from the ground observations also. Okay, New Zealand is welcome to participate. Well, I saw that, but our constellation will not be launched next year. We will define it and make it engineering, maybe a standard of instrument, for example, magnetometers, plasma detectors, and so on. So that will take a few years. So our the COSPAR constellation will not be happen in 1 or 2 years. So it will take a few years.
There's one question, G, on question 15 on how to involve the countries that are interested in space weather science but do not know how to go about it. This matter of capacity. Okay, this matter of capacity building has been at the forefront of our discussion, and we knew it would be coming. So what we've done is from our end, at least, I know that there are many training programs being set up in various countries. When there was a symposium in Israel, we visited places where such initiatives were being made. But basically, what we've done is we've included our panel on capacity building, which is a panel of COSPAR that organizes capacity building workshops every year, several of them, into the discussion. And the chair of that panel, Professor Carlos Gabriel, is involved, knows about the initiative, is coordinating with Dan Baker's and TGCSS members in order to make sure that whatever is needed in terms of capacity building for the area of small satellites for space science is being taken on board in their panel, and so that they can help answering that very question. How do we not just launch satellite, but also how do we enable countries where the expertise is lacking to become experienced in the domain? So this is also something that we are keen on developing.
Yes, thanks, Jean-Claude. When I look at all the questions, I think the interest is come. It's really bottom up. I'm very happy with that. And please, all the participants, please follow the what is going on with the task group. And we will in the near future, we'll organize definition teams and engineering teams and system designs. So please watch us and through the COSPAR headquarters website, and then you will not miss it. So all the questions you have been asking will be answered there in the near future. So we have another 10 minutes left for the meeting. And I invite any panelists to say a few words if you want. Okay, so if not, we can close the meeting. Thank you very much, all the participants, and please follow us. And I will also express our great thanks to EC Beijing, to Laura Bodis. And she had great help to us to organize this. And I hope EC Beijing can be involved in the near future for the further activities of our task group. Thank you very much.
Sorry, can I add?
Yes.
A quick word. I see that there are many questions that have been left unanswered. What we can perhaps try to do at the task group meeting is collect them, run them by the members of the task group, and try to provide through this the online forum that we have through the web page and other media that we can help develop, maybe a Slack channel in the future, answers to these questions as we are refining these answers. So that's one point I wanted to make. And the second point is at the end of 2021, and presumably we will have developed the concept much further by then, COSPAR is organizing a symposium, the 5th COSPAR symposium, which is going to be precisely on small satellites for space science. The organizer is Dr. Amal Chandran, who is also a member of the task group in Singapore. And the workshop will be held in Singapore in November, if I'm correct, 2021. So if you're interested, stay tuned for this, and you can already contact Amal and others to propose events for that symposium if you want to participate. We don't know yet, of course, whether it will be a physical meeting or completely remote or hybrid, probably hybrid. But there will be opportunity for you to propose sessions there and presentations there, so that this is incorporated in the program. Sorry that I wasn't quicker in adding these thoughts.
Yes, it's even sooner. We will have a COSPAR assembly next January in Australia, which is a hybrid online and physical. So if you watch our activities of this task group, we will have a seminar there also. So please follow us. And I agree that I saw more questions coming in, so we cannot answer all of them. We will keep these questions, and we will discuss those questions in our task group and provide general answers on the web. And please follow our activities at the COSPAR's website. So thank you very much. Thank you again. And let's close this meeting. Thank you. Bye-bye.
Bye-bye. Thank you.
Bye-bye.
Bye-bye.
Bye.
Bye.